Hello everyone, a big welcome to the next session. The 10 most important questions, the most asked questions to master your AI engineer and LLM based interviews. Before starting the session, I would like to just show you that what are the sources from which I have gathered. See, I have gathered the resources from all the trusted sources. You can just see the top interview questions for data science freshers, Gen AI, system design and AI. Questions such as what's the difference between fine-tuning and LLM using prompt engineering? How would you evaluate RAG performance of a Gen AI application and all these questions? Then I would like to show you one more trusted sources. While preparing for AI ML engineer interviews, I have curated this comprehensive list of interview questions mostly asked for Gen AI and LLMs. Guys, these questions are related to transformer and LLM architecture, fine-tuning and model efficiency, embeddings and vector search, and deployment and engineering challenges. Then again, one trusted source that I would like to show you from where I have gathered the questions. I would just like to show AI interviews are not easy anymore. The bar has changed. Companies are no longer asking basic ML definitions. They now expect RAG architecture, agent orchestration, LLM, internal system design thinking, failure scenario debugging, then LLM and Gen AI. What are the concepts that needs to be covered? So questions have been taken from these trusted sources. Again, one of them preparing for AI and Gen AI interviews. I recently went through a collection of 50 LLM interview questions that covers many of the core concepts every AI engineer must understand. Tokenization, embeddings, transformer architecture, attention mechanism, prompt, RAG, and all these. So guys, I would just like to share, yes, again, one more trusted source. You don't fail LLM interviews because the questions are hard. You fail because the fundamentals aren't clear. Fundamentals related to RAG, AI agent and MCP, and all these questions have been put here from where I have curated and from where I have gathered. So I welcome you all guys to this session, and I have curated and gathered the 10 most highly asked and very important questions that are definitely expected to come to these interviews. Okay, so the first question that you should always know is what is the difference between a base model and instruction tuned model? Okay, see, base models, they are trained purely on the next token prediction over large corpora, and the instruction tuned models, they add super fine tuning on instruction response pairs, often to align with outputs with the user intent, safety and helpfulness. I would just show you a very simple example. See, for example, base models versus instruction tuned model. If you just see this carefully, base model that are raw autocomplete, and they have been pre-trained on raw internet text, minimizes token prediction loss and no concept of answering questions. But the instruction tuned model, they are like task followers. If you just see, they have been trained on base model plus super fine tuning plus RLHF DPO, then fine tuned on instruction response pairs and aligned to follow internet and safety rules. So I would say this is the major difference between the instruction and the base models, and you can also see the difference in the output. Okay, so one of the highly asked questions, that what is the difference between a model, okay, base model and an instruction tuned model. Okay, so you can just prepare your answer, but yes, one of the highly asked questions that have been there in number of resources. Second highly asked question is how attention works in a transformer and why it scales quadratically. See, firstly, if you want to just read attention mechanism, one of the papers, that is attention is all you need, one of the highly cited papers from Ashish Vaswani, you can directly go, and he has only orchestrated, or he has only laid the foundation of attention mechanism. Okay, so you can just go and you can just understand what exactly the attention mechanism is. This is the paper, and this is open source paper. Directly you can just go and you can just read it. Okay, but yes, how to actually answer, what all points to cover in this question, the must include points, that should be firstly, explain how attention mechanism works in a transformer and why it scales quadratically. See, each token produces a query, key and a value vector. Then attention scores are calculated, which is what? Which is the dot product of each query with every key. Okay, and then softmax. Softmax is the activation function, okay, into the weights, then used to combine value vectors, and every token attends to every other token, and the cost is the order of n square in sequence length. That is why it scales quadratically. Okay, and which is why long context models rely on separate attention, sliding windows or false attentions. So what is attention mechanism? So you can directly just go to that paper and you can just directly read the definition. You can understand the architecture and why it scales quadratically. This is the explanation why it scales quadratically. Okay, so this was the second highly asked question in number of interviews. Then Third highly asked question is the definition of RAG and any project that you have made. Okay, so questions may be framed like what is RAG? Okay, retrieval augmented generation system, and when would you use it over fine tuning? Very important. I mean, what exactly is fine tuning and what exactly is RAG? I mean, what are the use cases and differences between them? Highly asked question. So you should be very prepared. So I would just like to give you an answer. RAG retrieves relevant documents chunks from an external knowledge base. Very important. From an external knowledge base at inference time and feeds them into context so that model can ground its answer. Okay, and fine tuning is what it is to change behavior, style, or format consistently. So a basic difference. I mean a very wide difference. Okay, production systems often combines both. RAG is nothing. RAG is an external knowledge base. Okay, and we use RAG when knowledge changes often. It is too large to break into weights, or you need traceability and citations. Okay, so I would just say that please prepare an answer accordingly, and you can also relate your answers if you have any projects you have done on RAG. Then the fourth highly asked questions that I saw was what causes hallucination in LLMs and how do you mitigate this problem? Okay, so basically what is hallucination? When model generates statistically plausible tokens, okay, what is hallucination? Whenever the model behaves incorrectly, okay, or it just gives you false responses, no, then we say that LLM is said to be hallucinated. Okay, so how do you mitigate it and what causes it? So model generates statistically plausible tokens, not verified facts. So there's no built-in fact-checking mechanism. So this is the reason why the LLMs hallucinates. Okay, and mitigation, how to mitigate it? We can have grounded RAG with citations, lower temperature constraint sampling, chain of thought of self consistency checks, and output verification or guardrails. Okay, so that is how we can just mitigate it, right? And also we can fine tune on refusal uncertainty examples so that model says I don't know when confidence is low. Okay, so these are certain points that you must include. Then fifth highly asked question is what is the difference between fine tuning, LoRa, PEFT, and prompt engineering? So firstly, you should understand LORA. Okay, that is low rank adaptation. I mean, you should know the full form of certain words and also the meaning. Then PEFT, that is parameter efficient tuning. Okay, and now the difference between fine tuning, okay, PEFT and prompt engineering. If you just see carefully, fine tuning is nothing. It updates all the weights. Okay, it is expensive, data compute hungry, and high customization. But if you just see LOR or PEFT, that is parameter efficient tuning, okay, using low rank adaptation, that freezes the base model, okay, and trains small low rank adapters. So you should just know that yes, it would freeze the base model. Okay, it is cheap, near comparable performance, easy to swap per task. Okay, and prompt engineering, that is no weight updates are there. Okay, in the prompt engineering, no weight updates are there. It steers via input design, and that is cheapest and fastest to iterate, but limited by context window and reliability. Okay, so I mean more detailed version of all these things you should just see. But yes, one of the highly asked questions in these interviews. Then this is a detailed table. You can just take a snapshot. Comparing prompt engineering, PEFT, that is parameter efficient fine tuning, and full fine tuning. Okay, so that is what you can just take a snapshot and you can just see, okay, what exactly are the differences. Then I would say the next highly asked question is how to reduce latency and cost in an LLM powered production system. Okay, guys, you should understand here certain points. No, you should always remember in this question: smaller distilled model where possible, cache repeated prompts responses, and batch request. Okay, so this could be one of the possible options. Then stream tokens to improve perceived latency, and we can use speculative decoding. We can trim context via retrieval, chunking, or summarization. Then route easy queries to cheaper models and reserve large models for complex ones. Okay, so yes, I understand not a much detailed one, but this is one of the highly asked questions that I have gathered. Okay, then what is temperature, top K, top P, sampling, and how do they differ? So you should just know temperature scales log it before softmax. Both are the activation functions. Okay, and more deterministic focused, and if it is lower, that means it is more deterministic or focused. If the temperature is higher, that means more random or creative. Okay, then top K restricts sampling to the K most probable next tokens, and top P, that is samples from the smallest token set whose cumulative probability exceeds P, adapts pool size dynamically. Okay, so you should also prepare these three terms, no, Temperature, what is the use of temperature, significance, top K and top P sampling, and how do they differ? A highly asked question that I have gathered. Okay. Then question number 8, how do you evaluate an LLM application beyond it looks good? I mean, what are the evaluation metrics for a LLM? That is highly asked. So you should have a detail. If any project is there, I think using that project you can enlist it. Okay. If not, then I think you can just include at least a BLEU ROUGE. Okay. So these are the two metrics. Okay, for summarization translation. Then exact match, F1 for QA, and embedding based similarity, right? F1 score, that is F1 score. Okay, for embedding based similarity. Then LLM has judge scoring against rubrics, human evaluation for subjective quality. So generally human evaluation is done for subjective quality and business metrics. Okay, business metrics, we have resolution rate and click through. Okay, and regression and golden data set suits to catch a prompt or model drift. Okay, and for RAG, we can measure retrieval precision, recall separately for generation quality. So you should at least have knowledge, no, of all the LLM metrics that you must have used in a project. Okay, so you can just make a table, and you should know the definition also and what is the significance of that. Okay, then highly asked question that you can find is, what is KV cache and how does it matter for inference? Okay, so you can just read the definition and you can just prepare an answer. Definitely that shall include KV cache and how does it matter for inference. So auto-regressive generation needs the key value vectors for all prior tokens for each new token's attention, and KV cache stores them, so each step only computes the new tokens. Okay, and reuses the rest one. Okay, so you can just prepare one answer, but yes, one of the highly asked question, that is KV cache. Design a LLM based system to answer questions over a company's internal documents. What's your architecture? So a highly asked question that they can give you one of those data set of the company, and they can just ask you to tell the architecture if you want to build a RAG pipeline using that data set. So how to do this? So that is one of the projects that you need to do. Okay, but yes, the architecture shall include ingestion, where chunking documents with overlap size to the embedding model context. Ingestion should be the first one, and here chunking of the document should take place. Then embedding plus vector store, we can use FAI says spine cone. Okay, so this is for search similarity and a search engine. No? Then prompt construction with source attributed context and then guardrails. Okay, so here you can evaluate, okay, monitor the retrieve quality. Okay, so this is, I would say, the 10 questions that you should always once look before going to any of the interviews. Okay, thank you so much, guys.